Hello, this is Mr. Newberry. Today we're going to start our Unit 2 videos with 2.1 angle pairs. Um, Unit 2 is going to deal with a lot of different angles and angles that are made by intersecting lines. Um, so the first thing we're going to talk about, and first term, is an adjacent angle. All right, adjacent angle. This is when you have two angles are adjacent if and only if they share three things: a common vertex, a common side, and no common interior points. All right. So the next slide, I'll kind of detail a couple different options of adjacent angles. Okay. So again, all of these things have to be present for them to be adjacent angles. Okay. All right. So here is a diagram where we've got points A, B, C, and D, and E here in the middle, and that is our vertex. Okay. E is the vertex. So what we have here is we have a lot of different actually adjacent angles. We're going to talk about one specifically here. We've got angle AEB, which is this angle, all right, and we have angle BEC. Now, these are a pair of adjacent angles. Now, let's see if it satisfies the three things, all right? They share a vertex. Well, they both share E as the vertex, AEB, BEC. All right. They share a side. Well, this side right here, EB, the ray EB, they share between the two angles. All right. Sorry, my dotted line, not too good here. All right. They share that side. Now, what they also have is the third thing, which is they don't share any interior points. Now, an interior point is basically a point that's inside the angle. So if I look at a point right here and I named it point F, well, F is not shared between the inside of AEB and the inside of BEC. All right. So in this case, they are not, right? They are not adjacent angles. Or I'm sorry, they are adjacent angles because F is not shared between the two. In fact, there's no points that are going to be shared between these two angles. Now, let me show you an example that satisfies a couple of these things, but not all three of them. All right. So if I were to say angle A, well, get our marker back up here. Angle AEB and angle AEC. All right. Now, these they satisfy two of the three things. They share the vertex, all right? They share a side. In this case, the side they share is side EA, the ray EA, all right? But there are points all inside here that are shared in both angles. They're in both AEB and in AEC. So in this case, they would not, all right? They would not be adjacent angles. All right, and one last example here. All right, here's another one that shares two properties but not all three. If we were talking about angle AEB and CED, all right, they share a vertex, all right, they don't have shared points on the interior, all right, but they don't share a side. Because they don't share a ray, they are not adjacent angles. All right, so again, they got to share all three parts for them to be true. The next term, linear pair. A linear pair is when we have two angles form a linear pair if and only if these two things are satisfied. They are adjacent angles and their non-common sides are opposite rays. Okay, now if you guys remember, opposite rays are the rays where if you have one going one way, one going the other way, and they share that point in the middle, okay? And they make a straight line. Sorry, mine's a little curvy, but they should make a straight line. All right. Now we've got some angles here Like down here it says, is angle AEB, angle BED, or angle CED and CEA a linear pair? Well, let's look at our first set here, AEB and BED. So angle AEB is this angle, angle BED is this angle. Now, does it satisfy the two things? Well, they're adjacent angles, share the vertex, share a side, don't have any shared points. So I know that these, okay, are adjacent, all right? Now, do two of their sides, the ones that aren't the same, are they opposite rays? Okay, and they are, because they start at E, one goes this direction and the other goes this direction, and they make a straight line. So that one checks both of those boxes. So they work out for a linear pair. Let's look at CED and CEA. All right. So CED is here. CEA, this angle over here. All right. Are they adjacent angles? Well, they share a side, share a vertex, no interior points shared. Yep, that's good. They're definitely adjacent. And the sides, the rays that aren't shared, are opposite one another, making opposite rays. Yep, that is also one. Okay, so that is a linear pair. Now, I like to think of linear pairs as kind of two parts to a straight line, right? They make that straight line, and the two angles put together have to encompass all of them. All right. Now we do know, like, one of the properties of a linear pair is that when you add the two angles together, they're going to equal 180 because they make that full straight line. Angle pairs, vertical angles. Vertical angles are two angles form a vertical pair if and only if they are the non-adjacent angles formed when two lines intersect. Okay. This is one of those terms that the name of the angle doesn't exactly describe it as well. Okay. But we use vertical angles a lot. All right. We use them a lot in geometry. So we need to know what these are. So with our vertical angles, okay, and the best way to describe them, we can write this out, but I think the best way is to look at an example. All right. And a vertical angle are angles that are, I like to call them opposite from one another. All right. So in this diagram, angles 2 and 4 are vertical angles, all right? Because they need to be non-adjacent, so they're not next to each other, all right? But they're formed from the same two lines, just on opposite sides of the point of intersection, all right? So 2 and 4 are vertical angles, they're a vertical pair. And 1 and 3 are also a vertical pair, all right? Because they are two lines, share a vertex, non-adjacent, directly across from one another. All right. So vertical angles, another way to think of them is they're straight across one another or opposite one another from the same two lines of intersection. All right. Supplementary angles. You guys probably recognize this term. A supplementary angle is when two angles are supplementary if and only if they add to equal 180 degrees. All right. So the measure of angle A plus the measure of angle B is going to be 180. Then they are supplements of one another. All right. So a lot of times we'll say, what is the supplement of a specific angle? Well, we're asking what the angle measure needs to be for both angles to add together to give us 180. All right. So supplementary angles are angles, and when you add them together, you get 180. All right. Now we can use algebra with our supplementary angles. So it says, given that angle A and angle B are supplementary, all right, find the measure of each if the measure of angle A equals 7x plus 9 and the measure of angle B equals 9x minus 5. So if we know they're supplementary, we know that when we add them together, they should equal 180. All right, so that's how we're going to set up our equation here. So we got 7x plus 9 plus 9x minus 5 equals 180. All right, combine like terms, 7x and 9x is 16x. 9 minus 5 is 4, a positive 4. I'm going to subtract 4 from both sides. And 16x equals 176. Now, I actually could do this one in my head, and I think dividing both sides by 16 should give us 11. All right, and in my head, what I did is I know that 16 times 10 is 160, and it's 16 more, so it'd be 11, would give us 176. So x equals 11. All right. Now it says find the measure of each angle. It doesn't say find x. Now we need x because now we can go back up and we could plug in 11 for x in both cases. 7 times 11 is 77, and 77 plus 9 is 86. So angle A equals 86 degrees. Let's see, 9 times 11 is 99. 99 minus 5 is 94. So angle B is 94. Now, these should add together to give us 180. Add 6 on to 94, you get 100. 100 plus 80 is 180. So they both check out. Okay. All right. Complementary angles, these are the same, almost the exact same thing, except now we're not talking about angles that add together to 180. We're talking about angles that add up to 90. So two angles are complementary if and only if they add to equal 90 degrees. Measure of angle A plus the measure of angle B equals 90 degrees. All right. Now, instead of calling them supplements, okay, they are complements of one another. All right. A good way to remember, and this is when people get confused between complementary and supplementary. Complementary, okay, think about the first letter of each alphabet. C comes before S. 90 is smaller than 180. So because C comes before S, C goes with the 90. S, supplementary, that goes with the 180. All right. If you are getting confused, just think alphabetically and then numerically they go in the same order. All right. A linear pair postulate. If two angles form a linear pair, then they are supplementary. All right. If two angles form a linear pair, then they are supplementary. And a lot of times I wouldn't call these interchangeable. I wouldn't call them interchangeable, but they're basically overlapping in their properties here. Again, if you've got two angles, right, and they are a linear pair, well, they're also going to be supplementary because the linear pair tells us they make this straight line, which means this angle plus this angle has to equal 180. The vertical angle theorem, if two angles are vertical angles, then they are congruent, okay? This is one of the biggest properties that we use within our vertical angles, and that's the fact that when you have, okay, lines that are straight across from one another, right, or angles that are straight across from one another, they are going to be congruent angles, all right? Now, I'm marking these with different hashes, so we got double here to show that these two angles, top and bottom, are congruent, and these two angles going this way are congruent. It doesn't mean all four of them are congruent, right? All it means is that the vertical angles, the ones across from one another, are going to be congruent.